Hello friends and welcome to today's lecture on the second part of alkyl halides. In the previous lecture, we had seen the methods of preparation of alkyl halides and the reactions of alkyl halides with a particular focus on nucleophilic substitution. As we saw in the previous lecture, nucleophilic substitution reactions are essentially of two major types, and there is a third minor type. We had seen SN1 reaction in the previous lecture, and now we will see the SN2 reaction and then SNI reaction. So, let us start with SN2 reaction. In the second part of alkyl halides. Given here is my mail ID. In case you have any doubts or difficulties, you can post them on YouTube channel or you can write to me. Let us begin with the second type of nucleophilic substitution, and that is SN2 reaction. So, I have given here an example of SN2 reaction. Okay, have a look at the SN2 reaction. Here is ethyl bromide. When ethyl bromide is treated with hydroxide ions act here as nucleophile, and ethyl bromide is the substrate. Bromide is the leaving group over here. So, hydroxide ions attack this carbon, bromide leaves, and the resultant product is ethanol plus bromide ions. Okay, this is the reaction of SN2 type. Why this is SN2 type is because when you measure the rate of the reaction is directly proportional to concentration of both ethyl bromide or the substrate and concentration of hydroxide ion, that is the nucleophile. In other words, rate determining step involves two terms, or this reaction is a bimolecular reaction. As we saw, this reaction is a bimolecular reaction because both the molecules or both the species are involved in the rate determining step. Now coming to the mechanism. The mechanism involves attack of the hydroxide ion on the carbon which bears the leaving group and loss of bromide in the same step. I repeat, the reaction is bimolecular and a single step reaction. Okay, so both these attack as well as loss of leaving group occur simultaneously, and it is a single step reaction. Now, because it is a single step reaction, the energy profile diagram looks something like this. Here is the alkyl halide or ethyl bromide. This is the transition state. What happens in the transition state is the bond between halide and carbon is partially broken and the bond between hydroxide and carbon is partially formed. Okay, so attached to this carbon has 5 valencies. These 3 valencies. Here is bromide. Let me correct it over here. Since we are seeing bromide, I will put here instead of chloride, bromide. Okay. And there is OH over here. So a sort of pentavalent, but the shape is trigonal bipyramidal. The transition state is trigonal bipyramidal. And since the transition state is sort of pentavalent, if there are larger groups attached to this carbon, they increase the crowding in the transition state. If there are larger groups, just see here, a small group doesn't increase the crowding. But if we have larger groups, I will use a different color for larger groups. Let me use blue. If we have larger groups over here, the crowding in the transition state increases. Just see, so much distance is less now between two groups. So the crowding increases. And because the crowding increases, the rate of the reaction goes down. Okay, so in other words, primary alkyl halides, which have two hydrogens and one alkyl group, react fastest, followed by secondary alkyl halides, and least reactive are tertiary alkyl halides, because there are all three alkyl groups over here. The size is huge, and because of the huge size, there is a lot of crowding, decreasing the rate of the reaction. Now, in the primary substrate also, look at this. If the primary alkyl halide contains about 1 to 3 carbons, the SN2 reaction is very smooth because the size is small. If it contains about 4 carbons, there is a slight reduction in the rate of the reaction. But if the number of carbons go 5 and above, SN2 reaction does not occur, and such substrates shift to SN1 reaction. Although they are primary alkyl halides, they shift to SN1 reaction because that huge alkyl groups in the transition state cannot be handled energetically. Okay, so what you have to understand is the reaction, the rate of the reaction, the mechanism, the energy profile diagram, and why is the reactivity so. Now coming to stereochemistry. Just try to understand the stereochemistry, and then it is very easy to understand why the reaction proceeds with complete inversion of configuration. Before we see why the reaction proceeds with complete inversion of configuration, here is a revision of your 12th standard concept. Okay, this is the structure. Now, if this structure, this can get converted to two different types. One form is OH comes from the same side. Okay, and therefore, this structure corresponds to retention of configuration. On the other hand, see, Br is on the same side as OH. Sorry, OH is on the same side as Br. So this conversion corresponds to retention of configuration. But if it happens other way around, that is Br and OH are on the opposite side. Look at this structure. Br was on your right, OH is on your left. And so this structure corresponds to inversion of configuration. We saw in the SN1 reaction that initially there is inversion followed by racemization, that is 50% retention, 50% inversion. But initial stages inversion remains. Now what happens in SN2 reaction? Just try to understand, this is the substrate. OH has to attack the substrate. Now Br is such a huge atom and OH cannot attack from the same side. Okay. So OH attacks from the opposite side. It has to attack from the opposite side. And because it attacks from the opposite side, the net result is there is inverted product, okay? Or there is complete inversion of configuration. Why complete inversion? There is no chance that some racemization can occur because OH cannot possibly attack from the same side. It has to attack from the opposite side. And therefore, SN2 reaction proceeds with complete inversion of configuration. Now, this is again a commonly asked question. Explain why SN2 reaction proceeds with complete inversion of configuration. Now you will have to write all the equation that I have written over here and then explain why OH has to attack only from the opposite side of Br, because Br is there, bond making and bond breaking take place in the same step. So OH cannot possibly attack from the same side. Okay. I hope this is clear to everybody. Now coming to SNI reaction. SNI reaction is a nucleophilic substitution reaction where the nucleophile is a part of the leaving group. Okay, this is something different. And the reaction therefore proceeds with complete retention of configuration. Okay, look at this. Conversion of alcohols to alkyl halides using thionyl chloride. Now, what happens in the first step? In the first step, HCl is lost. Okay, thionyl chloride structure can be written as S double bond O, Cl over here and Cl over here. Okay, so this Cl takes up the H and therefore oxygen gets attached to sulfur. And this is the structure, intermediate structure that is formed. Now what happens? This Cl attacks this carbon. It has to be on the same side. It cannot attack from the opposite side, right? As a result, this carbon becomes pentavalent. It cannot. So this bond shifts over here. Okay. Now as this bond shifts over here, SO2 is liberated in the reaction. Okay. First chloride has always been lost as HCl, and the second chlorine is incorporated in the structure. Now chlorine attacks from the same side as originally OH is, because otherwise it cannot attack from the opposite side, and so the reaction proceeds with complete retention of configuration. Okay. Now, these questions. These are the questions which have frequently appeared in the university exam. There are many more also. I have given some representative question. Now, here is a question. Discuss the SNI reaction and its utility. Okay, SN1 reaction does not give optically pure product. SN2 reaction gives an optically pure product, but it is of inverted configuration. If you want that of the same configuration, then you need to have SNI reaction. Okay, I will explain this question. How will you convert R2-chlorobutane to R2-butanol? If you start with R2-chlorobutane and do the SN2 reaction, then you will get S2-butanol, right? So, just think, how will you convert R2-chlorobutane to R2-butanol? Okay. And second interesting question, how will you convert R2-butanol to S2-butanol? Okay. Now here I will write the answer. This is R2-butanol. When we treat it with thionyl chloride, what we get? R2-chlorobutane, right? And when we treat this R2-chlorobutane with hydroxide ions and carry out SN2 reaction, what we get is S2-butanol. Okay? In a similar way, I want you to solve this problem. It may be two-step reaction, it may be three-step reaction. Okay, now last thing that I want to tell you is, this is a common question, write short note on SN1 or SN2 reaction. Now here, when there is a short note asked, you have to write the reaction, you have to write the rate of the reaction, the mechanism of the reaction, okay, the reactivity, energy profile diagram, and explain the stereochemistry. Everything has to be included in short. Okay? So, with that, we are ending this lecture. In case there are any difficulties, please feel free to write to me. And if you have appreciated the lecture, hit the like button and subscribe to the channel so that you get intimation of the next lectures uploaded. With this, I take your leave. See you in the next lecture with factors affecting the nucleophilic substitution reaction. Thank you so much.